Probability distribution, that is chapter 5. Section 5.1 is also probability distribution. In this section, we're going to introduce random variable, and we're going to talk about what is probability distribution, probability histogram, and then we're going to look at significantly low or significantly high values. So first of all, random variable is a variable that has a single numerical value determined by chance. So think about this. Let's say I have a two coin. I flip a two coin, and one side is head, another side is tail. So what are the possible outcomes? The possible outcomes are I could have head first time and then tail next time, and I could have tail first time, head next time. I could have head first time, head next time, or I could have tail first time and then tail next time. So these are the outcomes. So if I say, hey, how many heads, let's assume that that is our variable. Let's say x denotes heads in this flip, then it might be 0 head, like this. There are no heads here. It might be 1 head, it might be 2 heads. So these are the outcomes. So we can assign this outcome as a variable. That's called random variable. Okay. And probability distribution means, if you go back to the same examples, if you look at this possibility, you can find out the probability for different random variables, meaning what is the probability of getting 0 head out of 2 trials here. So 0 head means it's 1 out of 4. That means 25%. What is the probability of getting 1 head? Exactly. So these are the two cases where you might have, sorry, not this one. These are the two cases where you might have 1 head. So there are 2 possibility out of 4. So which is 50% chance. So probability is 0.5. And in how many cases you have 2 heads? Only 1 out of 4. So that means 0.25%. This column represents the probability distribution. So the probability distribution is a description that gives the probability for each value of random variable. Okay. So discrete random variable is where you have finite outcomes, and you can count your outcomes. Um, for example, flipping a coin, you can count your outcomes, like how many heads, how many uh, tails, and your outcome is countable, finite. Continuous random variable means, example, like let's say your variable represents body temperature. The body temperature could be any one number. Like for example, your body temperature could be 99 degree Fahrenheit, or maybe 99.01, or maybe 99.001. So any number between 99 to any maybe 104 or something like that. So that's a continuous random variable because you have infinitely many values. That's the continuous random variable. There are some requirements for the probability distribution. If we are talking about the probability distribution, there is a numerical random variable. The variable is supposed to be numerical. If you see a categorical variable, that's not probability distribution. And this symbol means the sum of all possible probability supposed to be 1. If you go back to this example I was giving you, like here, if you try to add all these probabilities, then it's supposed to be 1. Okay. So this symbol means summation. Summation means sum of all possible probabilities for outcome x, where x assume all possible values. Sometime when dealing with the calculation, because of technology approximation, you might see 0.9999 or 1.001. They are also assumed to be very very close to 1, so they are also assumed to be 1. So that is fine if you get that sum. And keep in mind, in probability distribution, the probability has to be in between 0 to 1. It cannot be less than 0, it cannot be more than 1. One example, let's say, just for one example, let's say in two baby birth, let's assume that X represents number of females in two birth. So these are the possibility. You could have, let's say, F represents female, M represents male. You could have, male, male. You could have male, female. You could have female, male, or you could have, female, female. So number of females, 0 females. In this case, you don't have any females, so that means the probability is 0.25. One female, you might have this situation where you have male first and then female, or female first and then male. That means the chance is 50%. And you could have both females, two females, which is 25%. That's a probability distribution. So if you try to look at here in this example, the value of X is numerical. The sum of the probability is equal to 1, and probability's value for different outcome is in between 0 to 1. So it's a probability distribution. So this is an example of probability distribution. Probability histogram, like previous chapters where we discuss about the histogram, if you plot a rectangular bar like this, where the height of the bar represents the probability for different outcomes, that's called probability distribution. So as you can see here, this is the bar for 0 female, and the probability of for that bar is 0.25. So the height is 0.25. 1 female, height is 0.5. 2 females, the height is 0.25. That's the probability distribution. The very same outcome can also be calculated by using this formula. So sometime we can represent probability distribution using formula. Okay. So one thing we have to keep in mind that probability distribution, whenever we discuss about the probability distribution, it's about the population. So whatever value we are going to calculate, that is parameters, not statistics. So we are going to specifically we are going to calculate mean, standard deviation, and variance for the population. Okay. So there are formula for finding the mean, standard deviation, and variance. So these are the formula. You have to first calculate the X times P of X, and then add all those possibility, and that will give you the mean, and then this formula gives you the variance, and this formula gives you the standard deviation. How do you calculate it? Just we can do it step by step. I'm going to show you some examples using StatCrunch. Okay, there is one more terminology that is called expected value. Expected value means in any scenario, what is your expectation? That is also called expected value. For any discrete random variable or for any outcome, the expected value is actually mean value of outcomes. So whatever outcomes you have, what is the mean value of the outcome? That is called expected value, and this is the formula we can calculate for the expected value. I'm going to show you some examples here. Okay, after finding all these values like mean and standard deviation using the formula we're talking, like this formula, we know any value, let's say this is your center, which is mean. Any value which is 2 standard deviation far from the mean, more than that value is called significantly high values, or less than this value are called significantly low values. Okay, so for the significant rule for the probabilities, you have to keep in mind, let's say X is the random variable, X success among n trials, that is assumed to be the significantly high if the probability of getting X or more is less or equal to 5%. It could be less or equal to 1%. This 5% is not rigid. It might be fluctuate. You might see 1% in some scenario. But if the probability of getting X or more is very, very low, those values are called significantly high values. Similarly, the probability of getting X or fewer value or less is very, very low. That value is called significantly low. Okay, so the real event rule for inferential statistics: if under given assumption the probability of particular outcome is very small and then outcome occurs significantly less or significantly greater, then we expect that the assumption is very rare. Okay, so that's the topic here in section 5.1. Let's do some examples and then use these values here. Before I jump into the problem, I just want to make sure that we understand the topics here. So fill in the blank. Our dash variable is a variable that has a single numerical value. So this is the random variable or random variable definition. A dash random variable has either a finite or countable number of values. Remember, it's a discrete. Discrete random variable has a finite or countable number. And then continuous random variable has infinitely many values. Okay. In a probability histogram, there is corresponding between what is that? Yeah, what is that? Variation, volume, and probability. Variation and area, area and volume, area and probability. In a probability histogram, there is a corresponding between one is probability and another one is area. Okay, area of histogram. Okay, and the blank of a discrete random variable represents the mean value of the outcome. The expected value of discrete random variable represents the mean value of the outcome. Okay, so let's do some of the examples. Let's start with problem number 1. This is the table we have given, and we need to find out either this table represents uh, what is the random variable, what are its possible values, and are its value numerical. So number of unlicensed software packages X, these are the random variables. So the random variable X, which is the number of unlicensed software packages, the possible value of those X is 0, 1, 2, and 3. The value of the random variable X are numerical. So this is the right one. The random variable is X, which is the number of unlicensed software packages. The possible value of X are this. Okay, is the random variable given in the accompanying table discrete or continuous? So this is the random variable and this is the finite, and this is the discrete, not the continuous. Okay, the random variable is discrete because there are finite number of the values, and what else? Because there are finite number of values. Fantastic. Okay, now I jump into the next problem. We need to find out either this is in a survey, cell phone users were asked which ear they use to hear their cell phone, and these are the options: left, right. Remember, these are not numerical values, so it's not random. So does the table show probability distribution? The first condition to be probability distribution, there are this condition. There it's supposed to be numerical value, the outcome supposed to be the numerical value, but in this example the outcomes are left, right, no preference, so this is not probability distribution. So the answer is no. The numerical value, the random variable X is categorical instead of numerical, so this is the answer. So because it's not probability distribution, we cannot calculate mean and then standard deviation. So these are the options. This is numerical. Households are randomly selected and partitioned into groups of 4. For those groups, the random variable X is the number of household with the printer. Determine whether a probability distribution is given. If a probability distribution is given, find its mean and standard deviation. I'm going to show you how to use StatCrunch to solve problem like this. You can open this problem here in the StatCrunch, and remember, to be a probability distribution, the variable has to be numerical. This is numerical in nature. The sum of this column has to be 1. I'm going to use this data and compute and expression command, and I'm going to add this column p of x. If you go to the function here, you're going to find out the sum function, sum. Where is that? That's going to help us to add this column in p of x, and that's going to give me, what is sum of p of x? This one is 1. So that means the outcomes are numerical in nature, and then sum of p of x is 1. And the third criteria to be probability distribution is the probability has to be in between 0 to 1. So in this example, as you can see here, all the probabilities, they are in between 0 to 1. So the answer is yes, this is the probability distribution. Yes, this is the probability distribution. Now the question is, how do you find mean and standard deviation? There are formula for finding the mean and standard deviation, like I showed you here. Mean, this is the formula, and this is the standard deviation. You can calculate this step by step manually by multiplying x times p of x and then adding all this value, or you can use the start crunch. For you are allowed to use the start crunch even in the test for this course. So just go to the start crunch, go to the stat, go to the calculator, go to custom. In the first place, values in x, choose x, weight in p of x. Now if you hit compute, it's going to show you different information. And then if you focus here, down here, you are going to see mean and standard deviation. So for this question, the mean of this problem is 2.421, but if you want to round it to the 1 decimal place, it would be 2.4. So that's the mean. And then standard deviation, from this calculation, standard deviation is 0.98. If you want to round it to the 1 decimal place, it would be actually 1, because if you round it to the 1 decimal place, that's supposed to be 1. Okay, so that's the mean and standard deviation we can calculate for the probability distribution using StatCrunch. So I am going to do one more question, and then we're done for this section. Refer to the accompanying table. So if you click here, you are going to get the table. If you click and open in StatCrunch here, you will be able to find the mean and the standard deviation. Go to the stat, go to the calculator, go to custom, choose variable from x column and variable from px column, and just compute. It's going to give you the mean, which is if you round it to the 1 decimal place, it would be 1.5. That's the mean. And standard deviation is 1.0. If you round it to the 1 decimal place, that means it's still 1. Okay, so that's the standard deviation. So that's section 5.1.